Hello guys, I am Nidhi S. Bagalwadi, your physics teacher, Sankalp Learning Solutions. So in the last class, we discussed regarding certain terminologies related to the spherical mirrors. Okay, today we are going to discuss how the images will be formed using the spherical mirrors, right? So let us consider certain points, that is how the images will be formed. Like the points will be related to how the light will be incident, on the spherical mirror. Okay, fine. So here let us consider three cases, where two cases I have already drew on the board. One more case I will be explaining later. So now let us consider a concave mirror, okay, whose reflecting surface will be inwards, and the parallel beam of light, the parallel ray of light is incident. This is a parallel ray of light which is incident on the concave mirror. So this parallel ray of light will be parallel to the principal axis. So when the parallel ray of light is incident on the concave mirror, the reflected ray of light, found to be pass or through the focus of a mirror. Okay, the reflected ray of light passes through the focus, principal focus of a mirror. So this is in case of concave mirror, when parallel beam of light is incident. Okay, now when parallel beam of light is incident on a convex mirror, the reflected ray, this is a reflected ray. Okay, so the reflected ray is appeared, it is not coming, it appears to come from a focus of the convex mirror. We know that the focus of a convex mirror will be beyond the spherical mirror, will be beyond the mirror, or we can say will be behind the mirror. So here it appears to come from the focus of a convex mirror. Here it comes or it passes through the focus of a mirror. In convex, it appears to come from the focus of the convex mirror. So this is when parallel beam of light is incident on the spherical mirrors. Now let us go to the other case, the second case, when a beam of or a ray of light passes through the center of curvature. What is center of curvature? It is the center of a sphere from which this spherical surface have been derived or detached. Okay, so when a ray of light passes through the center of curvature and incident on a concave mirror, so before going to this, we have to understand one geometrical concept. Okay. So here let us consider a circle. Fine. This is a center of a circle and this is a radius. The radius is the distance between the center point and any point on the circumference of a circle. So according to geometry, a tangent, a line which is passing through the circumference of a circle at a point of contact, the distance at a point of contact, it will be perpendicular, means 90 degree. It will be perpendicular to the radius of the circle. A tangent at the point of contact will be perpendicular to the radius of the circle. This we have to remember before going to this. Now, let us consider a ray of light is passing through the center of curvature of a spherical surface. Here we can draw the tangent. So, according to this law, the incident ray is normally hitting the spherical surface. So here what happens? The angle of incidence will become 0. It is normally hitting. Don't think it is 90 degree. It is going straight. Okay, going straight, not forming any angle and perpendicular to the tangent. So angle of incidence will become 0 here. So when angle of incidence will become 0, the reflected ray will also come in a same path. Will also comes back in a same path. Like this, the direction of incident ray, and this is the direction of reflected ray. So here angle of reflection will also become 0. So when a light ray passes through the center of curvature, the angle of incidence and angle of reflection will be 0. It is according to the law of geometry regarding the circle. Okay. Now, when we consider the convex mirror, here when a ray of light appears to pass through the center of curvature, it is not passing, it appears to be, okay, appears to pass through center of curvature. Here also same thing happen. Here if we draw the tangent, again the normal incident, so angle of incidence will become 0 and angle of reflection will also become 0 because it is hitting, it is striking the spherical surface normally. When a ray of light strike the surface normally, then angle of incidence, angle of reflection will be 0. Normally means 90 degree. Okay. So here it will be also 0. Fine. This is the case at center of curvature. Okay. Now, let me rub this. Now let us consider a concave mirror. Then this is the pole. Okay, this is a center of curvature and this is the focus point, principal focus. Let us think a ray of light is passing by through the focus point via spherical mirror. A ray of light is passing through the focus point through a spherical mirror. Now it is passing on a focus point. This is a ray of incident. Then the reflected ray will be parallel. It will be parallel to the principal axis. Whenever a ray of light passes through the focus of the principal axis, the reflected ray will be parallel to the principal axis of the mirror. So this is in case of concave mirror. Okay. Now let us see in the convex mirror. Fine. Now here what happens? Focus will be behind. Focus and center of curvature. Okay. Center of curvature will be behind the mirror. Behind the mirror. This is a reflecting surface. This is a opaque material. This is a reflecting surface. Now, when a ray of light appears to pass through the focus length, appears to pass through the focus point of the mirror, the reflected ray will be, again, the reflected ray will be parallel to the principal axis of the mirror. Parallel to the principal axis of the mirror. So this is how the image will be formed when the light rays passes through the focus of the mirror. So we learned three cases. The first one is when the light rays incident parallelly on the mirror. Okay. Then the next case is when the light ray is passed through the center of curvature. And the third thing is when the light ray passes through the principal focus of a spherical mirror. So in all the concave mirror it will be passing through, really it will be passing through, but in case of convex mirror it appears to pass through, it appears to meet, because the principal focus and the center of curvature will be behind the spherical mirror, which is impossible to say the exact or accuracy of the points. Okay, so this is regarding three cases of the image formation. After studying this, we can move to the image formation by a spherical mirrors. Okay, so let us learn more about these spherical mirrors in the upcoming class. Until that, have a nice day.